We have the impression that not everyone knows what systems engineering is for. That is why we want to help understand the issues whose implementation significantly improves the efficiency of the product.
We assume that there are qualified people in every other competency apart from the system engineering. This is a very important assumption. Systems engineering is not a guarantee of success. System engineering is a guarantee of optimality. It means a product that has smallest losses of resources, read energy.
To break free from organizational chaos, system engineering suggests moving in three areas related to engineering specific to a given product, for example, electronics, chemistry, mechanics, software. It can be any combination. Managing tasks resulting from the system schedule, but this is not project management, and supporting actions that are appropriate to the work environment in a given company or organization.
System engineering is nothing new. It is a solution well known all over the world and well described in many books. A valuable feature of teams that are experienced in operating according to the principles described in our training is the fact that many activities are simplified and described in an easy and accessible way.
We observe that when such a process is handled by people who lack experience, then complicated and extensive instructions appear, which do not bring added value, but only complicate the work and generate frustration among other employees.
We propose a solution based on 3 blocks. Each is important, but we consider that area related to engineering to be most important, most demanding and necessary. Without it, nothing will ever be created. The next block is management. Without effective implementation of tasks from this block, a product will be created, but not in expected time. The block that connects all activities is process configuration. For example, the area of supporting activities.
Surely, the engineering activities that need to be performed in the projects are obvious to everyone. But how to perform them and at what point can cause problems. That is why the process describes supporting activities that define the way of performing activities, such as verification of work results, reviews of project stages, maintaining documentation, responding to problems, respecting quality procedures, and managing changes.
The system process is complicated and therefore requires appropriate management. First of all, you need to define the strategy of action. Usually, these are procedures and standards that do not change very often in companies.
Knowing the scope of the project, you can divide it into stages and assign appropriately trained staff to carry them out.
Having the appropriate resources, you can start developing the concept and then submit the documentation into implementation. The stage confirming the correct implementation of the process is the verification of the correctness of the implementation of each of the process stages.
Unfortunately, risk often accompanies task execution. A well-prepared management schedule includes the action to be taken when the risk exceeds a previously defined level.
The stage that is the most demanding in terms of human resources is the engineering activity block. These must be experienced engineers with certified skills and preparation for work as system engineers. Failure to care of this will result in large financial losses and poor work results, the delivery of which will drag on for years.
A well-functioning team will quickly obtain information from the customer regarding their requirements and prepare a system architecture that allows for the allocation of each function to the appropriate systems blocks.
Such a structure allows for easy decomposition into functional requirements and simplifies writing requirements on three levels. The item, it is capability intended for the end user, for example, car or TV. Next one is subsystem, artificial layer for describing features. And third one is a unit, a layer for requirements addressed to competences involved in the implementation of physical devices. For example, electronics engineer, mechanics engineer, and also software engineers.
Architectural requirements must be verified first as integration testing to find out if it is possible to start the verification process for functional requirements. Otherwise, the company will again be exposed to losses related to duplicating tests for areas that do not work.
The last element of engineering process is handing over the work products to the customer. It is not only a finished device, but also documentation confirming that the entire process has been validated and has reached at least an assumed quality level.
Companies that do not use system solutions risk increasing manufacturing and production costs. Additionally, there is a higher risk that introducing even minor changes to an existing product will start a whole series of works from scratch. It means increased cost again.
We would like to invite all of those interested in the topic of system engineering and other training in a related field to contact the SIBA Foundation.